All right, we're going to continue on with our work in our polynomials unit, and this is a big important topic we're going to do today. It's called multiplying binomials, okay? And I'll start with an introduction and then we'll do quite a few examples. Our goal, though, before we do anything else, is to multiply something like this to get a polynomial in standard form. And I'm going to give you the answer. You might not see how we're getting the answer, but I'm going to give you the answer right now. And basically that's our goal, to turn the product of two binomials in parentheses into typically a trinomial, a quadratic trinomial in standard form. And I'll be honest with you right now that this is a little bit abstract and it's tough right now to make some connections to the real world, but I 100% promise you that when we get into quadratic equations and quadratic functions, the value of this will become really apparent. Okay, it's a real tool that we use to solve real world problems, but today we're really just focusing on developing a skill, a multiplication skill. So two ways to remember, and we'll apply these two ways actually there are a few ways with a few different ways of remembering this, and we'll apply them all to this problem I just showed you. Okay, FOIL stands for first, outer, inner, last, and it's just a mnemonic to help you remember to multiply every combination of terms in the first set of parentheses by every combination of terms in the second set of parentheses. So 2x plus 3 times x plus 4. Okay, so let's do our first two terms. 2x times x is 2x squared. Our outer two terms, 2x times 4 is 8x. I stands for our inner two terms. 3 times x is 3x. And L stands for our last terms. 3 times 4 is 12. We can combine the middle two terms together, and that's how we get a 2x squared plus 11x plus 12. This is the method that I use. I don't love just asking you to memorize a process without understanding why, and so we'll use some other methods here to help you understand why. Okay, there is a reason why all this works. The double distributive method is another way of remembering. 2x plus 3 times x plus 4. So basically what you can do is you can split the first term into two separate terms, and we have a 2x times x plus 4 plus a 3 times x plus 4. And then we could just distribute twice and add those two simplified pieces together. So we are distributing in here, and then we are also distributing down there. So continuing over to the right, we have a 2x squared plus 8x. And then down below, we have a 3x plus 12. Adding those guys together, making sure we're combining like terms carefully, we get what we need, 2x squared plus 11x plus 12. All right, you can think of this using an area model as well, and I use these area tiles, or I call them factoring tiles, a lot when we're actually factoring, which we'll get to in another video or two. But here we're going to show it for the multiplication process. So we have these, I call them tiles, over on the left, and they have some dimensions associated with them. It might look like, because I have a graph paper background on this video, that the first tile is 3 by 3, but it's not, okay? It's an x by x tile, which means it has an area of x squared, okay? So don't think that it's 3 by 3. This next one is x by 1, which means it has an area of x, and this last one is 1 by 1, which means it has an area of 1. Okay, so we can lay out some tiles to help us see what we need to multiply. So 2x plus 3, that's an x plus another x plus a 1, 2, 3. Okay, that's 2x plus 3. And then x plus 4 across the top. So here we have an x squared. So it looks like we have 2x squareds. So basically we're finding the area of this composite rectangle. We know the dimensions of it, x plus 4 by 2x plus 3. Let's find the area of it, okay? How many individual x's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of the rectangular tiles that have an area of x. And then how many unit tiles do we have with an area of 1? Those are these guys down here. And so that's 12 of them. Okay, so that's using an area model to show how to multiply these binomials together. So I will honestly use the FOIL method. I think that's the quickest method. But again, please don't just think of it as a method that your teacher asks you to just memorize without knowing why. Okay, either the double distributive or the area model really tell you why. Okay, but the FOIL method I think is just the quickest and most efficient to go through. So this guy, let's do it. 2x squared. The outers are 12x. The inners are minus 5x, and the lasts are 30. I'll do a little bit of color coordinating. So this came from the product of, let me see here, these two terms. This came from the product of these two terms. Hopefully this color coordinating makes sense. This came from the product of these two terms. Okay, I've already messed it up. The orange I missed. How did I miss the orange? Where did my 12x come from? Okay, I messed up the red. Okay, let's fix the red. Okay, so the red, 2x squared, my bad, came from this guy right there, 2x times x. Okay, the orange came from 2x times 6, the outers. The green came from the inners, and let's have the blue come from the lasts. So that's where the blue comes from right there, okay? Phew, I got it, but there's our answer. 2x squared plus 12x minus 5x minus 30. And let's simplify. Usually it's the middle two terms you'll combine. 12x minus 5x is plus 7x minus 30. There's our solution. Phew, we made it. Okay. Next one, let's see how far we have to go. We're going to do 3 examples total. So same deal, first outer, inner, last. First terms are x times 6x, 6x squared. Outer terms are x times minus 4. Inner two terms give us an 18x, and last two terms give us a minus 12. Combining the like terms, which again are the middle two terms, we have a 6x squared plus 14x minus 12. That would be our final answer. This last guy, let's just do a double distribution practice here. 2x plus 1 times x plus 3. So let's do 2x times x plus 3. And let's do a plus a 1 times x plus 3. Okay, so we'll distribute the top piece. 2x times x is 2x squared. 2x times 3 is plus 6x. 1 times anything is just itself, so let's do x plus 3. And we are going to add these two together, carefully combining like terms. We have a 2x squared, we have 7 total x's, and then plus 3. There you go. That's our final answer. That's a good place to stop right there.